Here we're doing another example of a phase plane, a phase portrait for a linear equation with constant coefficients, second order. This one is homogeneous. And so we look at the characteristic polynomial, r squared plus 2r plus 1 equal to 0. It turns out this is 1 plus r squared, and so it's 0 only when r is equal to minus 1. So we're only getting one exponential out of this, e to the minus t. And so we know from experience that the way to fix that is to have t times an exponential e to the minus t, that will also help solve the equation. And so, because when we differentiate this product, we'll get the t times the e to the minus t. When the exponential is differentiated, will also be a solution, but when t is differentiated, will give us another factor. So let's check. We take the derivative, we get minus c1 e to the minus t, and then again, this is the product, so we get c2 e to the minus t and minus c2t e to the minus t. When we differentiate again, we get x double prime. Here we had c2 minus c1 times e to the minus t, so now we get c1 minus c2 e to the minus t. And then when we differentiate this, we get minus c2 e to the minus t and plus c2t e to the minus t. If we look at these, if we take twice this one and add it to that one, we get c2 minus c1 twice and added to c1 minus c2, so we're just left with c2 minus c1. c2 minus c1 minus c2 is just c1, and then minus 2c2t plus c2t is minus c2t, and then when we add this, we get that c1 e to the minus 2 t again back, and the c2t e to the minus t back, and so that is in fact 0. And if we plug in the initial conditions, we get that x is a e to the minus t plus a plus b t e to the minus t. So c1 is a and c2 is a plus b. And if we take the derivative, we get what I have over there. And what we're plotting is we're starting at t equal to 0 at the point a, b, and then we're going to see how trajectories move from those points. So again, the phase plot will be in the x prime plane, and we will have some starting points for trajectories, and we plot some trajectories, and we plot a sampling of the vector field, and again, time will be implicitly represented by the trajectories, but the phase portrait shows us the behavior over time in the plane where we see x and x prime.